The death of the bridge honeypot. A single zero-knowledge state proof can verify the entire history of a Layer 2 wallet without the user ever interacting with the bridge. This is the end of the witness-based era where we trust multi-sigs or relayers to move value between chains. Instead of moving assets into vulnerable vaults, the Lagrange ZK-Coprocessor allows one chain to mathematically verify what is happening on another in real time. We are seeing a structural shift from active bridging to passive state-proof verification, which removes the single point of failure that has cost the industry billions. This mechanism turns interoperability into a data query rather than a high-risk transport protocol. And the way it handles these queries depends on a specific off-chain architecture. Inside the ZK-Coprocessor mechanism, think of the ZK-Coprocessor as a specialized GPU for the blockchain. Smart contracts are notoriously bad at heavy computation or searching through historical data. They are designed for simple logic and state updates. Lagrange offloads these data-intensive tasks, like calculating a user's average balance over 6 months across 4 different L2s, to an off-chain prover network. These nodes execute SQL-based queries and return a succinct proof to the mainnet. The design trade-off here is clear. You sacrifice the immediate finality of an on-chain calculation for the massive scalability of verifiable off-chain big data. This is how the protocol enables applications to move past simple swaps and into complex, data-driven decentralized finance. But this off-chain work is only as good as the security layer that signs off on it. State committees and restaked security. The protocol's security does not rely on a new, unproven validator set. Instead, it uses Lagrange state committees, which are essentially ZK-Lite clients secured by eigenlayer restaking. As of June 2026, the network is powered by over 85 institutional node operators, including major entities like Coinbase and Kraken. These operators stake assets to guarantee the validity of the state proofs they generate. If a committee signs off on an incorrect state, they face cryptographic slashing. This creates a shared security zone that scales with the underlying economic weight of Ethereum itself. While other interoperability solutions require you to trust a proprietary relayer, this model forces you to trust only the math and the capital at risk. This foundation is what allows the system to scale into what the team calls an infinite proving layer. The infinite proving architecture. The recent mainnet launch in late May 2026 introduced a hyper-parallel proof generation system designed for internet-scale throughput. Unlike traditional ZK provers that process tasks sequentially, this architecture distributes the workload across the entire network of 85 operators simultaneously. This isn't just about speed, it is about cost. By parallelizing the generation of proofs for rollups, applications, and cross-chain states, the protocol aims to lower the overhead of being omni-chain to near zero. However, this level of decentralization brings its own challenges, specifically around coordinate latency and proof aggregation. The system must now prove it can maintain this performance during the upcoming June 4th token unlock, which represents a 15% dilution of the circulating supply. This event will serve as the first real-world stress test of the prover network's economic stability. The real implication. The transition from bridges to state proofs signifies the end of the fragmented liquidity era. By combining the ZK-Coprocessors data handling with the state committees, shared security, developers no longer need to build for a specific chain. They build for a unified state. The protocol's reliance on SQL-based queries means that on-chain data is finally becoming as accessible as a web database, but with cryptographic guarantees. For developers and analysts, the takeaway is that interoperability is no longer a transport problem, it is a computation problem. The successful late May mainnet deployment proves that verifiable big data is now a production-ready primitive. The signal to watch now is the network's throughput during the June 4th unlock, and whether the prover nodes remain committed to the work-based tokenomics model as the float increases. If the latency stays low during this period of high volatility, the narrative of the omni-chain application will finally have the engineering backbone it has lacked for years. Subscribe for more